Next we have Telnet. Now, Telnet is going to be a remote terminal connection. So Telnet allows us to, if we are going to telnet into another computer, then we open up a remote terminal, what looks like a command prompt, into either that computer or that remote switch or device, and it's allowing us to have a connection. And that's going to be running over port 23, and Telnet can be configured as UDP or TCP. Now, it can be configured UDP or TCP because it's unencrypted. Telnet, all the information that we send when we're connecting to a device via Telnet is all encrypted and it's all clear text. So it is a protocol that we want to get replaced. It is a protocol that we want to use a different one for, especially if we're sending login information, because if we telnet into a box, if we telnet into a computer, we want that computer to be set up so that you can't just start issuing commands. You can't just start saying, oh, hey, computer, send me this file, do this, do this, do this. So that computer will request login credentials. And if we're connected over Telnet and we enter login credentials for that computer or for that device, that's all unencrypted going over our network. So just like HTTP, if someone's on our network sniffing that, they can easily pick that up. So we want to replace that with something else. But Telnet is a remote terminal connection running over port 23 that can be TCP or UDP oriented. Mostly replacing Telnet is our SSH. Now, SSH is an encrypted connection between points which either can act as a remote terminal or can transfer data. And TCP or SSH runs over typically port 22 TCP. But wait, you said? We already talked about port 22. You have a good memory. We talked about port 22 when we were talking about secure file transfer protocol. So why are we using the same port? Well, the reason being, and back in our secure file transfer protocol, our secure file transfer protocol needs a way to encrypt that data that's going back and forth. So how does it encrypt it? Well, it encrypts it with SSH. So when it's transferring that data back and forth, we're using a file transfer like protocol, secure file transfer protocol, but it's secure because it's encrypting that data by transferring it SSH. So SSH is its own protocol. We can connect to a device simply by using a secure shell. That's what SSH stands for, is secure shell. We can connect to a device simply by using a secure shell to its correct port, and that port can be changed. But we can also use SSH as part of secure file transfer protocol in order to securely transfer files to that same port over SSH. So that's why we say this protocol is over another protocol. HTTPS transfers over SSL, which is another protocol that we'll talk about later. SSL doesn't have a typical port that it uses because SSL, Secure Socket Layer, runs over different protocols. So SSL will work with HTTPS to make sure that this HTTP information is encrypted. SSL also works over a secured version of LDAP, Lightweight Directory Access Protocol, which allows us to make directory changes. And it uses SSL, it runs over SSL to encrypt that. So just like SSL runs over HTTPS, we can have our SSH running over a file transfer protocol in order to keep it secure as well. And then lastly, for these remote over here, we have RDP. Now, RDP stands for remote desktop, and this is the port that Microsoft Remote Desktop application is going to use by default to initiate a remote desktop connection. This is going to run over port 33389, and it's going to be TCP or UDP. Now, if we're in an internal environment where we need to initiate these remote desktop connections between clients because we have desktop support that initiates remote desktop connections, then that's all and good. But we may not want someone outside our organization attempting to initiate remote desktop connections. So this is where being able to block particular ports with our firewalls come in handy. We can set up a firewall, we can set up a DMZ, or we can set up an internal firewall that is filtering data coming into our network from the internet, and one of our block rules is to block RDP connections. So if someone is trying to initiate an RDP session through our firewall is going to block any RDP protocols. It's going to close off port 33389. So that's where that's how our firewall is used with these ports and protocols. Firewalls can block ports, they can block protocols, or they can just block everything that they aren't allowing through. If we had a firewall that the only thing we needed to allow through was web pages, all we may open on that firewall is port 80 and port 443. Because if we open port 80 and port 443 incoming, we're going to be able to receive standard HTTP pages, and we're going to be able to receive HTTPS. So we're going to be able to receive the internet pages through that firewall. So we can open up those ports and then have a rule that says block everything else. I don't want to allow Telnet connections into my network. I don't want to allow SSH connections into my network. I don't want to allow RDP connections into my network. So that's how we use our knowledge of these different protocols and their port numbers in order to determine our security posture and determine what ports we want and protocols we want to allow into our network.